What is up, Algebra 1? This is lesson 76. Our objective is, how do you solve absolute value equations? Before we get into solving absolute value equations, which I guess maybe you should know what they are, they're just equations with absolute values in them. Let's say simply, easy enough to understand. Let's just do a quick recap on what absolute values are. First of all, absolute values are the absolute value of a number is its distance from 0. So for instance, the absolute value of negative 3 is going to equal to 3, because on a number line, here's 0, 1, 2, 3. Over here is negative 3, so this is 1, 2, 3 steps away from 0. Likewise, the absolute value of 3 would also be 3, because it is 1, 2, 3 steps away from 0. Now, to take this into the idea of an equation, what if I were to ask you something like this? The absolute value of x is equal to 3. What could we plug in there for x? Well, notice, here's an example that would give me 3, and here's an example that would give me 3. So this one actually has two different answers. So to solve something like that, when you have an equation, if it's more complicated than this, the first thing you're going to do is isolate the absolute value. It means get the absolute value by itself. And then you're going to do what's inside the absolute value, which in this case is x, is equal to the positive version over there. Or you could say what's inside is equal to the opposite of the number over there, negative 3. So notice x equals 3 is a solution to this. If I plug 3 in there, it'd come out to be 3. Or if I plugged x equals negative 3 in here, it would also come out to be 3. So it'd have two different answers for this. Alright, so let's see if we can continue working with that same idea. So this one, notice the absolute value is already isolated, meaning that the only thing on this side is the absolute value of this, but still the absolute value. So what we're going to do is we're going to say x plus 3 is equal to 16, right? What's inside is equal to this. Or x plus 3 is equal to the opposite, negative 16, right? Because if this came out to be 16, whenever I plug 16 into the absolute value, it would come out to be 16. Or if x plus 3 came out to be negative 16, if I plugged that in here, negative 16 would also come out to be positive 16. So either of these would make it true, so now I just have to solve each of these equations just like I would normally. So I'm going to subtract 3, end up with x is equal to 13. Or, if I subtract 3 over here, I'd end up with x is equal to negative 19. So you can either write it like this, or the proper way to write it is to write a solution set, which is a squiggly bracket. You write the smallest number, negative 19, comma, and then all the rest of the numbers, and close out. So this would be our solution set to this, negative 19 and 13. Here, example 2a, notice the absolute value is not quite by itself. So the absolute value also has something else outside of it. So I need to see if I can get rid of that. To get rid of that, notice the 5 is multiplying by the absolute value. So opposite of multiplying is to divide. So these 5's reduce to 1, and I just end up with the absolute value of x is equal to, and then 20 divided by 5 comes out to be 4. So now the absolute value is equal to 4, which means that I either have x is equal to 4, or I have x is equal to negative 4. Well, it doesn't require any solving, so I can just say negative 4, 4. Alright, let's try another one. Again, this absolute value is not by itself because there's numbers outside, so I need to get those numbers outside away from it. So then I'm going to divide both sides by 4 because this 4 is multiplying by that absolute value. Those 4's will reduce, so I end up with absolute value of x minus 2 on the left hand side is equal to 20. So now, notice this absolute value is by itself on the left-hand side. and I have a number over here. So now I just need to split that up. I can say x minus 2, what's inside, is equal to the number on the right, or what's inside is equal to the opposite of the number on the right. Again, because if this were to equal 20, that means this expression would equal 20. Or, if this were to equal negative 20, that means this in here is equal to negative 20, and the absolute value of that would come out to still be 20. So either of these will make that a solution. So let's just go about solving this. I'm going to add 2. So I end up with x is equal to 22. Or if I add 2 over here, I end up with x is equal to negative 18. So my solution set is going to be negative 18, 22. And if this kind of notation seems new or scary, it's just a way when you have more than one answer to say, hey, look, all of these are my answers. So these work for like, if you have 100 answers too. You just say like, all of these are my, what we call our solution set, or our answers to the original equation. So one more on this slide here. Notice this is not by itself. There's a minus 2 over here. So then I'm going to go ahead and add 2 to both sides. So I end up with absolute value of x minus 6 is equal to, well, negative 2 plus 2 is 0, right? So it's just equal to 0. So whenever I split this apart, notice I would end up with x minus 6 is equal to 0. And then my other option would be x minus 6 is equal to negative 0, which is just the same thing as 0. So in a few special cases, whenever you have the absolute value is equal to 0, you won't have 2 answers, you're only going to have 1 answer, because notice this is the exact same thing as that. So I don't even really need this one over here. So then I'm just going to solve this, add 6 to both sides, and end up with x is equal to 6. So normally, at this point, we could just say, hey, look, that's my answer, x equals to 6. But another way to write that, using those, continuing with that solution set, we could just say, like this, 6. So either one of those would be a proper way to write that. Alright, now looking here at example 3b, we notice that the absolute value of something is equal to negative 8. Now, we want to just say like x plus 4 equals negative 8, x plus 4 equals positive 8. However, wait a second. Remember at the beginning, whenever we had the absolute value of negative 3, what did that number come out to be? A positive number. The absolute value of 3 came out to be a positive number because absolute values always output positive numbers. Okay, because it's talking about the distance, and we don't ever talk about like, oh, I live negative 8 miles from the school. No, we always say we live 8 miles from the school. So for the absolute value to equal a negative number is illogical, because the distance cannot equal a negative number. So for an equation like this, whenever you have isolated the absolute value and equals a negative number, that's whenever we would say no solutions. No solutions, because no number can I plug into absolute value will output a negative number, because absolute value always outputs a positive number. Let's try a little application here of this. It says a thermostat in a classroom is set to 21 degrees Celsius. That's a 69.8 degrees Fahrenheit, just so you know. The thermostat will turn on or off if the recorded temperature is plus or minus 1.2 degrees Celsius of this setting. What would be the maximum and the minimum temperature for this classroom? So maybe you're thinking, let me just take this temperature, 21 degrees Celsius, and add that. Take this temperature, subtract that, and those will be your two numbers. And that actually is correct. But let's see if we can take this one step further and see if we can apply what we've learned today about it. Remember, it turns on or off whenever the difference between the actual temperature in the room and its set temperature is bigger or smaller than this. So remember, the difference of something, we would write X is the actual temperature of the room. So whenever I subtract that 21 from it, if it is more or less than this, it will turn on the air conditioner or turn off the air conditioner, depending on what the case is. So this, the distance, or the difference between them, if it is equal to 1.2, that's whenever it turns on or turns off, that would be the maximum and minimum temperatures. So over here, I'd say X minus 21 is equal to 1.2, or X minus 21 is equal to negative 1.2. So all I need to do is solve both of these, so I'll add 21. So X is equal to 22.2, or whenever I, let's see here, add 21, it's going to be like subtracting, comes to be 19.8. So this is my minimum temperature of the classroom, 19.8 degrees Celsius, and the max temperature is going to be 22.2 degrees Celsius. Alright, if you haven't seen it already, your homework is on page 490. You need to lesson practice all the 74s and then one more of your choice. Good luck, guys.